If you pass, guys, if you pass electricity through water, it will break down into hydrogen and oxygen gases. Water has disappeared.
Okay.
Water is no longer there. Water is defined as H2O. Water is defined as H2O. It has disappeared.
Yeah, but now it's
Huh?
it hasn't really disappeared though.
Oh my God!
But it's gone.
I know. But you could just
There's less water.
You could get it back though.
Doesn't mean that it isn't gone.
No, but to say disappear, that means it's gone. So like.
Yeah, it's gone. It can come back. It
No,
can
no, no. Okay,
reappear.
okay. So,
Yeah, so it's
Bianca, the matter is still there,
Yes.
but it's no longer water.
Exactly.
It's demonstrably not water anymore.
And now we're on the same.
That's exactly what I said. From
It
the
isn't.
start.
It isn't there anymore.
All right. Did a Cheeto just fly?
Yeah.
Wow, I have good peripheral vision, like just in the.
I saw that.
All right. So anyway, 5-second rule. Are we gonna?
No.
I'll eat it.
As it turns,
I'll eat it. Tell me I won't.
Stop.
Dude, he just ate the. Tell me I won't. Eat it.
as it turns out, you won't do that.
Put hand sanitizer on.
You won't. You won't.
Is that a Polaroid?
Yeah, actually.
All right. Eat it. Just eat it.
No, it won't.
Eat the Cheeto.
Mr. White, we have a saying in Spanish, so it's lo que no mata engorda. If it doesn't kill you, it's gonna make you fat. So if that Cheeto is not gonna kill you, you're just gonna gain a few calories.
I agree.
You're welcome, guys.
Which podcast is better class?
He ate the floor Cheeto.
Wow.
That's. She was kind of gross at
I
this
wiped it
point.
off with a paper towel.
That's not how that works.
No, actually, okay, hold on. That is actually how it works. So, one of the biggest topics in chemistry is called surface chemistry. It's where solids, only the what reacts with things? The surface. So if you scrape off the surface of, for example, a floor Cheeto, there's no longer anything from the floor that could be on that Cheeto.
But what's on the floor makes it tastier. Like,
Well, and if worse comes to worse, you have like 180
oh, you're adding more like seasoning.
I do. No, I don't have 100, dude. I have like 100. All right.
School spice, as they say.
So, if reactants disappear, then products appear. And so, we don't just necessarily want to look at it at how fast the reactants are going away. We could also, if we take a step back and examine it, look at it based on how fast products are appearing. And then the rate at which the overall reaction proceeds. So the third one is kind of like just looking at, how the whole thing is going. The first one you're looking only at. The second one you're looking only at. Okay. All reaction rates are found by looking at the change in concentration over a period of time. So guys, this is yet another chapter where everyone's favorite concentration is back. Well, how do we most commonly study concentration in this class? Molarity. And molarity is defined as what over what?
Moles over liters.
Moles of solute over liters of solvent, which is always, in this class, water. Welcome back. So just to catch you up, Ashritha, I ate a floor Cheeto and we just started here.
How?
We're travel fast.
Wait, did you see the?
All right. So, Ashritha, this is called kinetics. It's all about how fast reactions happen. For reactants, we look at how fast they disappear because reactants are used, so they disappear. Products appear and they appear.
Duh.
Okay, so do you guys remember sometimes we've studied things with the idea A plus B equals D plus E? Now, if we use this as our kind of example reaction, then the disappearance of a single reactant could be looked at like this. Now, why is it negative?
It's disappearing.
Because it's disappearing. Very good. Because normally the rate is always a positive value. Because guys, are we allowed to have a negative concentration? Well, we could, right? If the concentration is going down. So by forcing another negative in here, we make it so the answer is always going to be. Does that make sense to everybody? And so then the rate of appearance of a single product, notice what are we not going to put here?
Negative.
Because if you're guaranteed to always have more, even if it's a very small amount more, then your value, your delta will always be what? Positive. Does that make sense? Whereas this first one, it would always normally be negative, so we force it to be positive by throwing a negative in it. Because we always report rates as a positive value.
That's dumb.
Yes, sir.
Is this going to be on the reference sheet or is this something we have to memorize?
Let's take a look at the reference sheet together, shall we? By together, I mean me up here. There's a bunch of stuff from kinetics, but none of this yet. This stuff you gotta know.
Aren't we gonna do thermodynamics again? Isn't that like part of this? Right.
Wait, is there thermodynamics in kinetics?
Yes.
No, because remember, kinetics is all about the speed. If you notice, all throughout this year, we have occasionally touched on how fast something happens, but then I quickly say, oh, but we're going to cover that more in kinetics. So now we're finally there. So, as I hope you all have realized as this year has progressed, every topic in AP Chem intersects with all the other topics of AP Chem in one big web, okay? So it's just a matter of which way you want to start. So choose your own adventure. Only I chose the adventure for you, okay? It's like a choose your own adventure book, but I chose the page order. So really, it's just a regular book for you guys.
Thanks, I guess.
Okay, so the rate at which one species appears or disappears can be used to find other rates, and the reason that works is because the whole thing in chemistry is that in our reaction, what do we have in front of all the participants in a balanced reaction?
E.
The coefficients. So how many uppercase A's do I have for every uppercase D?
1.
I have lowercase a versus lowercase d. What if lowercase a is 1 and lowercase d is 1? What's the ratio? 1 to 1. What if it's 2 and 1? 2 to 1. What if it's 1 and 2? 1 to 2, okay? And because of this, the actual rates of reaction, or rates of different parts of a reaction, are all interrelated. Because, okay, let's just say they're both 2, okay? 2 and 2. If 2 A's disappear, how many D's are going to appear? 2. So you see they're related, right? So as a result, we can actually use the coefficients and each of their individual rates to equal each other. Now, real quick, before I do anything else, why are these two negative? Because they're disappearing and we're going to force them to be positive. Very good, Solomon. Okay? And then, what do you notice? Are we just using the coefficient straight up? What do we have to do to the coefficient? We have to reciprocal, whatever you want to call it, math, fancy term. We just put 1 over it, okay? You got to put 1 over the coefficients, all right? And yes, this stuff that you're seeing here, you do have to memorize. This is not on your reference sheet. Yes, sir?
Just to make sure, the reason why the reactant side for A and B both have a negative is because they disappear.
Correct.
Being forced into the negative.
Because remember, we know reactions are reversible from equilibrium, but even in that case, we always treat them as if they're going in the direction we've written. If you want it to go the other direction, what do you have to do to the reaction, guys?
Reversing.
You have to flip it, right? And then what does that do to your K value, guys? You gotta put 1 over it, right? Okay. Let's advance here. Anyone still need this one?
Yes.
No worries.
How's your spring break?
Fantastic. I am very well rested. Did you guys appreciate the no AP Chem homework?
Yeah.
Yes.
Lately.
Do you normally
Because I
assign
had a
homework?
lot of homework from other classes, so.
That's awful.
Well, it's BC.
Did you guys all see my announcement on Canvas?
No.
Okay, reviews are gonna be every Tuesday and Wednesday in the month of April. You do not have to go to any of them. You do not have to go to all of them. You can pick and choose. You can leave early. You can come late to them. They're gonna be from 2:45 p.m. to 4:45 p.m. on Tuesdays and Wednesdays
No work.
in April. Natalie,
Okay, 2 questions. When is the AP exam again?
May 2nd. That's why it's only in April.
Wait.
Wait, that's the same day as the AP Gov exam.
I think so. I think we're the first.
Oh no. And that's the Monday after grad batch. Wait,
And
why?
also, are they gonna put?
Yes.
Yep. It's the Monday after grad batch. It's fun. Yeah.
On paid, you're joking. Oh my god.
Oh,
Oh, wait.
Oh no.
Oh, but that's like the 20.
I didn't know this.
It's the 19th to the 23rd.
This is the first year ever in history where chemistry is in the afternoon.
Yeah.
I don't have to wake up early. I'm not coming to school.
AP Chem's almost always been early in the morning.
I still gotta go to school.
I could get a 5.
We still have to go to school. We're gonna do AP Gov in the morning. It's the only one I have where
Hold on, what's up?
Well, I have another test in the morning. I have the ACE test. All the ACE tests are on the morning for that day.
On May 2nd?
Yeah, my general paper exams that day.
There's a chance, you know what, you'll have to ask them, you'll have to talk to them. There's a chance you'll do the makeup on one of those. And the reason I say that is because they're 2 separate companies. So I think there's a chance you might be forced to like do one of them in a makeup, because I don't know if the 2 companies, because with AP it works because it's the same company, so like the schedule is aligned, right? So you'll have to ask about that.
From the way it's looking like, if everything is like, there's like a 5-minute margin before the first test, the test ends and the next test starts.
Yeah, that's dangerous. Let me call this.
Yeah, that happened to me last year. I had,
With ACE?
no, not with ACE, but with the ACE test.
No, but AP is fine because it's the same company, so they can
No, it
always.
wasn't fine. I had AP Calc BC, and then 5 minutes after I did.
Yeah, but you were able to take your exam and you did it.
Wait, what is A?
It's Cambridge program.
AP Physics and AP
Actually, I'll look it up later. We gotta keep going. Shh. All right. So guys, a lot of you who are in calculus, you may have heard of tangent lines.
Yeah.
Guys, don't book a tangent.
So,
Are we gonna have to derive?
Okay, calm down. Shh. Guys, let me ask you a quick question. You know, I'm your wise leader. Ladies and gentlemen, do you have to know how an engine works to drive a car?
Yes.
Yes, of course you do.
Is there anything about the engine in the driving test?
Yes.
Yes.
How you start it.
I've never done the driving test. But
So my point is, if you know about calculus, you can appreciate this more. If you don't know about calculus, doesn't matter. We don't need to know how calculus works to drive calculus. Okay? So, anyway, guys, when you have a curve, you can find the instantaneous rate by taking a tangent line and taking the slope. The tangent line is obviously straight. Now guys, before I move on, why do you think the concentration over time is a curve? What have we always said in equilibrium? The closer you get to equilibrium, what do we say about the rate?
It slows down.
Slows down. And how about the further you are from equilibrium?
It's speedy.
It's faster. Guys, does air come out of a balloon faster when you first let go of it or when it's almost all gone?
You first
When
let
you
go.
first let go of it, it goes really fast. And then what happens to the balloon? As it's still got a little bit of air, but what happens to the balloon when it's like a quarter of its size?
It falls over.
Slows down.
It's not going as fast, right? Like when you first let go, it like, okay, same idea here. It slows down. Notice it's going really, really, really fast, and then what's it doing, guys, as it approaches equilibrium?
Slow down.
It's slowing down. However, we can take an instantaneous rate by picking a point and the slope of the tangent line. Okay. Now, let's look here. Guys, does it make sense that the three different components, NO2, NO, and O2, does it make sense that they have different graphs? Yes, sir. Go ahead. It's the styrofoam because the other one was stolen.
Again?
The can?
Hold
And
on.
now we're on a big styrofoam piece.
Hold on. Can
And
can
then
you,
if that one is lost, we've got its brother.
Mr. White? Can you go back for like 5 seconds? Okay, thank you.
All right. So guys,
Can we do an iodine swap reaction?
no. All right. So as you can see here, you can watch a video of it. So as you can see here, guys, does it make sense that the NO2 is going down in the equal but opposite fashion of NO?
Wait, hold on, let me think about this.
So NO is going like this, but NO2 is going like
Because
this.
it's negative, it's the negative part. It's A.
Well, because it is a
Yeah.
reactant,
So
right?
it's disappearing.
And it still has the same exact shape though as the NO because what do they both have in front?
2.
Very good. Now why would the O2 have a completely different curve? Let's go with Chance.
Because it's equal to half of NO
And does it make sense that this is about half of that?
Yes.
Is that what you guys were going to say back there? Yeah? Okay. All right, so let's look at an example here, guys. We've got 2AB. These aren't actual elements, guys. This is just a example. 2AB yields A2 plus B2. Guys, what do we mean when we say time is 0? This is before anything happens, right? So at time of 0, what do you notice about all of these particles? Which one of these are they? All.
ABs.
They're all ABs. There's no B2s or A2s, right? And do these numbers make sense down here when we say 0 and 0 for A2 and B2?
Yes.
And then we say 15, for these. But what about when we get over here? Is it all the same again after 60 seconds?
No.
Real quick before we move on, because it may be important. How many seconds are in a minute, guys?
60.
And how many minutes are in an hour? Okay, keep that in mind. All right, so AB is now 5 molarity, A2 is 5 molarity, excuse me, and B2 is 5 molarity. So, oh, sorry. Anyone still need this one?
Yeah.
Because what we're going to do on the next slide, we're going to calculate their rates.
I'm confused.
About?
I'm sorry, I think I was copying something down and I missed the explanation. So, as more time goes on, the molarity drops?
This one. It went from 15 to 5.
Oh, because, never mind.
But look what happens to A2 and B2. They
go up. Okay.
went up. Alright, I'll give you guys another couple seconds here. Did you guys have a good break?
Yes.
Yeah.
I'm excited.
Exhausting, what happened?
I went to state competition with the year.
Congratulations.
superior.
Did you win?
Yes, I got superior, so.
Good job. I'm proud of you.
But that was like the first part of break, and then I went to my friend's house for another 2 days, and I just slept the entire time. And then I got back, and it's college through, looking at progresses and doing this and doing that, so. I got to sleep for like 2 days of break.
Well, I'm glad you're back.
Oh, I'm tired again. I don't want to get up this morning.
Is anyone more refreshed now than they were before?
I mean,
No.
arguably.
I'm a lot more refreshed.
I need to get up on Monday to be here for rehearsal. Come see how it goes.
Anyway, guys, let's move on here. So, guys, does it make sense if we're talking about the disappearance of AB? Does it make sense that, we ended at 5? We're going to do 5 minus 15, and, it's all going to be over 60 seconds. The reason that is, guys, what's 60 minus 0?
60.
Okay, so it's 60 seconds. And so then 5 minus 15 is negative 10, but then this negative does what to that negative?
Cancel each other out.
So this should be 10 over 60. So our rate is going to be 0.1667 molarity per second. Now, for the appearance of A2, what we do is we'll do 5 minus 0, because notice it's 5 minus 0. And then over 60 seconds, so then it's 5 over 60. That gives us 0.0833. Okay, now, that's how we could calculate it if we did appearance and disappearance, right? But we could also have cut out this work and instead taken this rate and figured out that the rate of A2 is equal to 1 over 2 times the rate of AB. Because remember what we said, you could do 1 over the coefficient times the rate equals 1 over the coefficient times the rate. And why do we not have anything in front of this one? What was the coefficient in front of A2? And so what it would be, should we have written 1 over 1 here? Maybe for clarity, right? But do we need to write 1 over 1 right here? No, but for clarity, maybe it would have helped. All right, and we could have just done 1/2 times this, and voila, is this number 0.08335, the same as this number 0.0833.
Yes.
Pretend there's a 5 there. Yes.
Is it because they have the same coefficient that we can do that?
No, well they have different coefficients. This is a 1 and this is a 2. That's why it's 1 over 2.
I was talking about A and B. Hold on.
These are both rate A2s.
Oh, okay.
It says or, because this is an alternate way. Instead of doing this all over again, you could have just multiplied this 1 times 1/2.
Because of the 2.
Because there's a 2 in
that's
front of
the A.
AD and only a
okay.
1 in here.
Oh.
Thomas?
Where'd you get the polarities from? Okay, so if you're doing a question like that, it will show you all the stuff.
It'll either give you the molarities or give you a quick way where you can figure them out.
Okay. And
Like
then-
maybe they'll give you the grams or the liters and stuff like
And
that.
since it's a delta, you subtract the initial.
Final minus initial, exactly. And you should never have a negative pop out because you're supposed to, if it's disappearing, have a negative that cancels out the negatives. Yes.
Okay, so because we found the rate of appearance for A, so for the rate of appearance of B, it'd be the same thing, right?
Yeah, B would be this one.
Okay.
Because it's the same coefficient, so it'd be
So the
1
rate of-
times this equals 1 times that. So
So
yeah.
the rate of appearance is the same for both, right?
Right. Because the coefficients are the same.
Will there ever be a question where it wants us to find the molarity for kinetics using like equilibrium or something like?
Yeah, there could be some cross-discipline stuff. Yeah.
Okay. Is that usually FRQ? Like.
Yeah.
Okay.
Like there would be different broken down steps.
Yeah.
So then, what you could do, let's say you had a brain fog moment and you forgot equilibrium. You could still get the points for this by just jotting down 5 molarity.
Yeah.
You'll take the L on that part, but then when you use that 5 molarity, and if you do it right, here, you'll get the points even though the answer's wrong.
Yeah. Okay.
Yes?
What if the coefficient for B was different? We can't use
Okay, very good. So let's say, hypothetically, let's say there's a 3 there.
Right.
What we would do is 1 times this, because there's a 1 here,
Right.
equals 3 times B's rate.
Okay.
And then we would just divide this by 3 to get rid of the 3 on the other side, and then that would
Oh,
be
you
the
would
same.
divide it by 3?
Well, or actually I guess multiply, because it would be, this would
3
equal,
times that.
yeah. Like this would equal 1/3 times B2, so then you would multiply times 3 to get rid of it.
Oh,
Like you gotta write it out, but basically it's 1 over the coefficient times that matching rate.
mm-hmm.
So it would be this equals 1/3 times B2's rate. So then to get rid of the 3, you'd have to multiply the 3 to both sides.
Oh, okay. Okay, so you would do, like, let's say, like, it's the same equation, but there's a 3 on the B2. You would do 1/2 times, you would do the same, like
No 1/2, no 1/2. Like, or are you talking about like this number or this number? Which one are we starting with?
I was gonna do, like, I was gonna find A2. Because the only reason we can find A2 through, like, the second part, like the OR, is because the coefficient is 1, right?
Yeah, there's a 1 here. Okay, so you're saying if there was a 3 right here on A2.
Yeah, sure.
Okay, if there's a 3 on A2, it would be 1/3 right here. And we'd have to actually multiply 3 times 1/2 times this rate. Because like you want this rate A by itself.
Oh.
Like 3x.
Like you have to put 1, what makes this a little confusing, it has to be 1 over the coefficient.
But I thought we were doing the coefficient of AB.
You have to do the coefficients for both. It's just this one's a 1.
Oh. That's.
Okay. Alright, now everyone's favorite, rate law. I say everyone's because you guys have no idea yet. So,
Yay.
rate law will help us find the rate of the overall reaction. So, if A plus B yields C plus D, then our rate law is going to be rate equals, yay, we have another K in this class.
No.
This time it's a kinetics K.
Yeah.
What was that? Is that worse? or-
Equilibrium Ks.
Oh, equilibrium. Okay.
So, it'll be the concentration of A to the M power times B concentration to the N power, M and N.
Whoa, what are M and N?
I'm glad you asked. M is the reaction order for A, N is the reaction order for B.
I have a question.
Yeah.
Why is M not double N? Like how W, like U and W have the same relationship, but M and N don't? That's dumb.
Double N. Yeah, I like that.
Double N. It
Because
would make.
English, like many other languages, was just kind of put together over hundreds of years.
Yeah, but like, come on. How did no one see this? It would be perfect.
Michael, I wish you
What
were
if
there at the
W
beginning
came
of
after?
alphabet.
I wish I
It would've been
wasn't.
so much easier.
They didn't have baths back then. Okay, that would have sucked.
Well,
Oh, I read my answers like that.
all I'm gonna say to that, Michael, is we're here now. All right, so
Can we call double N just in this class?
no,
No.
it's
Dang
M.
it, that'd be hilarious.
It's M. All right. So guys, let me tell you, I believe rate law is on the formula sheet. It is not. You must know this. You must know this.
Sucks.
Let's go.
Are you, okay, how do we find the reaction order?
We're getting there.
Are we gonna be given the K, or are we gonna have?
No, okay. He asked a great question, guys. Sometimes you'll be given the K.
So we're gonna have to calculate
Other
the K.
times you're gonna
sometime?
figure out the K.
Oh no.
Are these calculator questions? Oh,
These have to be calculated.
Well, no. Actually, because of the method we're gonna use to solve these, you can actually do a lot of these without a calculator. And it's because, ladies and gentlemen, are we allowed to solve for multiple variables in this class? We can only ever solve for how many variables at a time?
4.
1. So as a result, we're going to do systems of equations plugged into each other. Is what we're
Oh
gonna do.
god.
Can I drop out of this class yet?
I think this.
No, guys, this is the easiest chapter. Relax. Yes, sir.
So the rate is only like disappearance of reactants, like.
Yeah.
Okay. So even though like it's talking about the rate of the
Like
overall
for rate
reactant-
law. Yeah, for rate law. Yeah.
All right.
All right, guys. So, more information here about reaction orders M and N. Reaction orders cannot be predicted from the balanced equation. This is key. Although, like everything I tell you in this class, we're going to break this rule later, but I didn't say that. So, reaction orders cannot be predicted from the balanced equation.
Yeah,
They
mostly
are
they can.
only found through experimental data.
Unless they aren't.
So, we can have 3 different reaction orders. So M and N, this is the first thing that's going to help us make this actually really easy. M and N separately can only be 0 order, 1st order, or 2nd order, which means that corresponds to the numbers 0, 1, and 2. So this is, like, this part was kind of scary, right? But now, over the next few slides, it's going to actually become simpler and simpler as we add more nuance to this process.
Have you ever read Dune?
Oh my God, what an amazing book. The movie was great.
You talked about it when
Yeah,
it came out.
I says.
Yeah,
Now
I did.
remember?
No.
Just remember, guys, fear is the mind killer.
Okay.
I don't get it.
It's just a reference.
Reference to the books.
And the movie technically, but mostly the books.
Are you a fan of Timothy Chalamet?
You know, I hope he bulks up for the future Dune installments.
You don't like Mr. Skinny Boy?
No, he's fine. It was fine for the first movie. I just hope, you know, I just hope they feed him some hamburgers, you know, and put him through some Iron Man competitions, you know. Actually, Iron Man might be bad because of the running. No running for him. Only weightlifting.
Why not running?
He needs some gold. He needs to get
Okay, not running, but he can
Okay.
sprint. We'll let him sprint.
Sprinting, fair enough.
Hello, this is Mr. White.
He's gotta have them legs.
Hey, I'm Mr. Green.
Thank you.
He is not.
I'm gonna
Yeah.
get home.
No problem. All right. So let's move on here. So guys, a 0 order reaction. This is when doubling the concentration of that species or any other change will have absolutely no effect. No effect. Because what's anything to the 0 power?
1.
So, in other words, if your M or N is 0, then that, whatever that exponent was attached to, will be 1, and so then that rate will be equal to its constant. So in other words, no matter how much you dump in there, the reaction stays the same. Avi, you had a question?
Yeah, can you go back 1 second real quick?
Did you know that there's currently a Dune board game?
Is it any good?
It's decent. It's decent.
Do you have it?
No, I don't have it, but
Or do you play it on Tabletop Simulator?
no, I borrowed it from somebody.
Oh, okay. So it's good though?
It's decent. It isn't like the book, but it uses the characters.
Oh, you know, I repaired my Xbox,
Wait, which one?
an original Xbox.
Oh, original.
Oh, the classic.
Yep. I'll probably be bringing that kind of stuff in after the AP exam, and then you guys can study, or you can be with the cool kids, you know, and play games. All right.
Wait, do you have
What
four
exactly will we
controllers
study
so we can all
for?
play?
Study for a single FRQ to make for a final.
Yeah. Video games though?
Yeah.
Listen, video games down.
Mr. White, what did you play on your Xbox?
Can we bring in video games?
So guys,
Is it an option?
I think 0 order is pretty self-explanatory, right? It's either M or N or both, but generally one or the other will be 0.
So it's like water.
So,
Pouring water.
as a result, when you have concentration versus time, So guys, this is one of the key components of kinetics, is they will sometimes throw a graph that looks just like this at you. And the difference between the three different orders, 0, 1, and 2, is going to be readily visible in their graphs. And you can identify them based on which axes give you straight lines. For 0 order, which y-axis is giving it a straight line? What does it mean if it's just in brackets, guys? Concentration. So guys, if it's just pure concentration versus time, and you have a straight line, that means you don't have to know anything else. You could just exclaim that it is
0 order.
0 order, okay? That is key. That is worth so many easy points on this AP exam to be able to realize you just gotta look here. No math, no anything, you just look there.
0.
Okay, let's now, let me go back. I know some people are still writing. Let's digest this. So guys, remember, if it's just a pure concentration, remember concentration isn't always in molarity. Sometimes it's just in brackets around the name. Yes, sir?
I'm going to guess that first order is the curve, and then second order is an S. Am I correct?
Well, first and second order will also be straight lines, but we'll have a different thing on the y-axis.
Okay.
And if we had the same y-axis, you're right, they would be curved, which is why you know it won't be one of those, or it won't be 0 order.
Okay.
All right, guys, let's, you guys remember, any of you have little siblings or cousins or something where they play with that thing where they put the blocks in the hole like a cube, they gotta put through the square, and then the circle, they put through the circle, and the star, they gotta put through the star hole.
Those ones are always
That
infuriating.
was fun though when I was like 3. That was a fun game.
So basically, this is gonna be like that game, so I hope you guys passed that game as children.
Wait,
Alright,
wait,
I'm
Mr.
sorry.
I have a question.
So-
When you did that, when you were younger and did that, did you not just try to force them all to the same hole?
Yeah, it didn't work because they're designed special.
No, but like, what if it
Use
wasn't?
a hammer they gave you.
What if?
Yeah.
What if they
Okay.
weren't designed well? Everything went through one hole.
For the graph again, I like this information. It's because of where it intersects the y-axis. That's how we know that it's.
No, it's because of what is on the y-axis.
Oh, what is on? It's only the thing.
When it's concentration in a straight line, 0 order. Don't think anything more of it.
Concentration and time on a straight line.
Yeah.
Thank you.
That means it's 0 order. Okay, now let's talk about first order. Guys, in a first order, if you double the species, it will double the reaction rate. And let's think about that for a second. If it's first order, what's our exponent? And anything to the first power is the same thing. So if you double that same thing, what's going to happen to your answer?
Double.
It'll also double. So here's an example. If this is to the first power, 2 to the first power is 2, right? So then 2 times x, it'll be twice as big, right? And what if we multiplied it times 3? It would also increase times 3 because it's to the first power.
Are we gonna get a graph for this?
Stay tuned.
Dang it. I'm gonna clear out space for the graph.
So is the second order you quadruple, right? Yeah. Spoilers on that.
Has that whiteboard been there since Christmas?
Yes.
It's scuffed. Are you gonna get rid of it?
I don't know, it kind of brings me joy,
I mean, like, it brings me annoyance. So,
Well,
Duality of
we
man.
can't make everyone happy.
can we all, like, redo it?
Oh, like with Easter bunnies and little eggs?
I suppose, but like I was saying, it just looks horrible.
Keep it very, religion neutral. Just keep bunnies and eggs up there,
Could be.
Why? What's up with bunnies giving eggs anyway? Who thought that was a good idea? Bunnies don't give eggs.
Well, it's nice when you have holidays like that because then, everyone can kind of have fun because it's like you separate out the,
Church and state.
yeah.
No, but like, hold up.
I for one, really like doing Easter egg hunts. Should I do an Easter egg hunt with you guys?
Yes.
Are you gonna put radioactive elements in the eggs?
All right, shh.
Mr.
No, I'll
White.
just, one of the eggs will contain an extra credit pass for only one.
Mr. White. But why is it a bunny giving out eggs? Bunnies don't lay eggs. Why not an
All right,
Easter
shh,
sparrow?
Stop questioning it. All right, so second order reactions. Guys, we will not be getting graphs for these because those graphs involve calculus. And that will be later. That's later. Okay, guys, second order, as Bianca stated, will quadruple if you try to double it. Because what's 2 squared?
4.
4. Yeah, and that's because it's the second power. All right. Anyone still need second order? Pretty self-evident.
I'm going first. You know what I mean? Like,
Well, hurry.
Come on, Victoria, come on.
Assembly start, Mr. White.
I don't know.
Can we all go?
Hopefully never.
It's for the ring.
What if we all take a field trip as a class?
Nah.
Yeah.
Why do you want
I guess money for me.
I mean, I said field trip, not go to the ceremony.
All right. We done writing yet? Hurry up.
What if you
Faster.
This is so much
Faster.
concentration.
Oh, then it would be 9x. Like what I hope crypto does.
That's
Oh
what
wait,
everyone
are you
wants
still
to
holding on to the hope of crypto?
Oh no, it's increased a lot. I don't know if any of you invested?
No.
Mr. White, I have a question.
Dogecoin is up. It's now at 16 cents.
Mr. White, I have a question. What exactly is your opinion on NFTs?
Oh, NFTs are a huge scam and a distraction, but they're kind of cool because they're keeping the flame alive.
What flame?
Crypto.
Mm.
All right, we all good? Moving on.
Couldn't you
So,
argue that NFTs
the overall
are the same thing as
order,
crypto?
guys, to kind of circle back, what we just explored were the individual orders 1, 2, and 0, 1, and 2. Now we're going to examine how we do overall order. So we're going to revisit the rate law, which is rate equals K, concentration of A to the M power times B to the N power. And we're going to realize that overall order is M plus N. So guys, if M is 0 and N is 1, what's the overall order? Because 0 plus 1 equals?
1,
What if they're both 1?
2,
Then it would be 2. What if one of them is 2 and the other one is 3? I'm sorry, what if one of them is 2 and the other one's 1? I just gave you
3,
what if they're both 0?
0.
Okay, so you guys see overall order isn't too bad, right? You just add M plus
and
N. All right, so moving on here. Oops. So as you guys can see, as you guys can see, now we're going to explore K. Remember we kind of shelved K for a moment, now we're back to K.
No one's going to do it.
Good morning, Bobcat. This is Mr. Patu. Just teachers, thank you so much for handling the mental health.
Oh yeah, we totally did.
Yeah.
So I hope you
I am
received
so
a lot of
mental
information that is beneficial to you and to your well-being. Teachers also, the sophomore assembly, sophomores, 10th graders only, please release them to the theater. If you have a predominantly 10th grade class or an all 10th grade class, please accompany them to the theater and be with them. Thank you.
Let's go.
So we're all 10th graders,
All right,
right?
so moving on here, the rate constant. Ladies and gentlemen, if the order of reaction is 0, the basic formula will be rate equals K.
Yeah.
Really straightforward, right? The units will be, oh, guys, what does it mean if you have something to the -1 power? It means it's 1 over it, right? So these all make sense when you think about it because they're all technically over seconds, right? See, seconds and equals seconds, seconds. So these are all per second, right? And this is actually really good that you see this here because they've reported like this a lot on the AP exam. Guys, when you see something to a negative power, it's 1 over that, okay? So
What about 4? Like if it's 2 and 2, what about 4?
you're gonna see, we're gonna get to that a little bit later.
But like, why not have it here?
There's a reason, and we're gonna explore that.
Okay.
Like, there's actually a really nifty, like, physical, logical reason. We'll get there. But guys, you see here how it says units for K? We're gonna have to remember that. This is often the question that will be asked is, what are the units for K for this? And so what you have to do is figure out what the order is and then remember what the units for K will be.
Bye-bye.
Different units.
Damn, that's menacing. Wait, was that possible? Yeah.
Bye, Ernie.
Can I come peek into the auditorium?
Bye, Avi. Bye. Avi, don't.
No.
Mr. White.
What if they get lost? We all gotta help them get there. Okay, it's a long walk. What if he passes out from dehydration?
Huh?
I second
Mr. White, I feel like you should stop just to respect that they're not here anymore.
Nah, we'll see.
There's still one more, there's 3.
They can join the Discord.
Guys, basically you gotta keep this in mind. You know what I always say? Write this down on a note card.
I mean, like,
but guys,
no
you
cards.
can actually kind of figure this out on your own as well. Because, hey, be good. Do your homework. You gotta figure this out on your own because these are the units you have to cancel out. Alright. Let's do an example problem together. 3 experiments were conducted at a specific temperature for the following reaction. 2NO plus 2H2 yields N2 plus 2 H2Os. We've got experiment 1, 2, and 3. Find A, the rate law, B, the rate constant at this temperature, and C, the order for this overall reaction. So guys, we've got a problem here. Because we could totally plug this one and this one in for, what's our generic formula? A plus D plus E, right? Well, we could totally put this in the rate law as this would be A, right? And this one would be B, but what are we missing?
D and
Well, no, remember rate law doesn't have that. Remember, here's rate law? We have the A and we have the B, but what are we missing, guys?
K.
And
the order.
but we can only ever solve for one variable. So we are gonna cheat a little bit here. This is exciting.
We substitute?
Yeah, we have to switch it around.
Yeah, we're gonna do some substitute. So guys, if we take a look here, what do you notice about reactions 1 and 2?
They have the same.
They have the same concentration.
And then what do you notice about 2 and 3, but with a different reactant?
They have the same.
And we've also got the rates too, I might add, and the rate is going to be what goes here. So we've got this, and this, and we've got several rows of data, right? Say that again?
No, I'm just thinking ahead. Like they're gonna cancel out eventually.
Yeah. So here's what we're going to do. We're going to create our new thing where rate 1 equals 1 and 1 here. This will be from row 1, or experiment 1 right here, right? We'll use this, this, and this.
Oh, that's
Okay.
part of the question.
And then rate 2 we'll put down here along with all of its stuff. We're going to divide them by each other. Okay? And so, look here, we got rate 1. Here's the rate for rate 1, 0.09. That's why we put that one here, rate 1. And then rate 2, look, we got it right there. And that's why we'll put that one right here. And then we'll put their rate law formulas above each other. What do you notice right here, guys? The 0.3 to the m, what can we do to those?
They can't.
And then what can we do to the k's?
They can't.
So then it's just going to be whatever this is equals 0.2 to the
Power
over 0.1 to the power n. Guys, let's see how much you remember from math class over the years. If you've got two numbers to the same variable exponent, what can you do with both of those numbers? So then 0.2 divided by 0.1 is in fact equal to, and then look, 0.09 over 0.0225 is equal to, and what's the answer? 2 to the n equals 4. What does n have to be?
2.
And remember, m and n, so in this case n, can only ever be equal to 0,
1 or 2.
1 or 2. That's one of the reasons this works so nicely, is that your answer should only be 0, 1, or 2. And so by doing all this, we have found that n equals 2. All right? And so we're going to need to do all of this again to find m. But I'll give you guys a second because I know we're still right. Like, kinetics seems a lot more complicated than it ends up being. What it ends up being is like this. Well, we're going to do this all again for m, right? And then we'll have m and n.
M and M.
And then, think about it, we will have m, n, a, b, and the rate, so then we can find k.
That was an interesting way of saying K.
Yes? Someone's out, go ahead. All the other teachers are violating the rules, why can't I?
Yeah.
Laws.
The rate law.
We don't need laws. We just want.
You were there for that.
Well, it's like they say in Pirates of the Caribbean, they're more like guidelines anyway.
Yeah.
All right, let's take a look now to find m, or did anyone still need the first part? Okay, to find m, we're going to compare 3 and 2 together, because look, we can wipe out these 2 with that. So,
why does 3 go on top?
That is completely up to you. They did it, like it doesn't actually matter, because it doesn't matter which one you put on top, because either way, these 2 will be the same number on this particular one. So then obviously m has to be 1 when you get to the end. They just, for whatever reason, chose to put 3 on top. I think it has to do with, it was a lot cleaner in their head that this over this would be 2/3 instead of
1.5.
like 3 over 2. But I mean, honestly, you could have done it either way.
Okay.
Yes?
Alright. So I get, like, we did, like, the rates, right, of the experiments.
Okay.
And then we found n.
N. And now we found m.
Oh, we found n because they're,
Because we look at,
We crossed out
for
n.
this type of problem, and I almost guarantee you this will be on your AP exam, this type of problem, they give you 3 rows of data, just like what you saw here. 3 rows of data, you find the 2 rates, m and n, the orders, and then at the end we're going to find k by putting those orders in and using one layer of data, and then it's only k that's missing.
Okay, perfect.
Okay, so in the chart, you know how they like give the like initial like concentrations? Is there like, and then 2 of them are the same?
Yeah, oh, that's another thing. It has to be 3 rows of data, at least. Sometimes they'll do 5 or 7, or sometimes they'll do a lot of rows of data, and you just have to find the rows where you got 2 that are the same, and then the other 2 that are the same.
What if there are none? Will there ever be a scenario where none of them are the same?
No. It's because this is accepted that you keep doing this until you get similar ones. That's how you solve these. This is what I'm showing you is the accepted way to solve this.
Okay, so there will always be like 2 of the same concentration.
Now, they might try to trick you by putting like 5, 7, or 11 rows of data. So they might try to like scare you. But typically, if they're being kind, it's just 3 rows of data. Because 3 rows is the minimum to have 2 overlapping.
You know, wouldn't we be calling College Board kind a massive exaggeration?
No, most years they are pretty kind. Like most, but it's like cruelty through kindness, because what they do is the trend has been making the exam too easy, so then they have in their head how many people they want to pass, so then they just make the curve so it's much harder to get.
That's dumb.
Right? No, we always do better when the test is much harder because you guys get a really good understanding in here. See, when they make the test too easy, then it makes it much more cutthroat.
Yeah, because then like you could get a high score and still like not.
Well, but then it's easier for people to guess their way through, and then it muddles the results, right? Like if a test is easier, then more people should pass, right? And so that's where the problem comes in, because they only ever want about half of the kids to pass this test.
Why?
That is something only they know the reason to.
I mean,
why calculus is 80 to 90% nationally, but ours is always only 50? I don't know.
Probably something to do with colleges and credit they give.
You're probably absolutely right. But that's like, out of our control. We're going to fight the best we can within the rules that we've been allowed. All right, so when you do this, guys, we're going to do 2 here and 1 here. Guys, quick note. If this had been 0, what would happen to this whole part? Because anything to 0 power is equal to 1. All right, and so what do we do to find k now? We'll just pick any row of data, right, and plug it all in here with this is 2 and this is 1. There we go. Perfect. Something you guys might want to focus on when you have, because I know you guys have tons of free time. After you finish this homework, you should probably kind of play around with all the units, and see how they're canceling and all that.
Hey. That was like a loud whisper.
What happened? Did I miss something cool?
No.
Not cool?
Something not cool.
Okay. Or wait, was it not cool or was it just lack of cool? Because I feel like not cool is its own like.
Yeah, it was lack of cool.
Okay, because you just know what I'm saying. How not cool is like its own. It has its own mythos attached to it.
That's not cool, man.
All right, let's move on here. So one last thing to point out, because M and N were 2 and 1, the overall order is then going to be 3, because overall order is equal to M plus N, so 2 plus 1 or 1 plus 2 equals 3. Yeah. Oh, remember this slide? We've seen it so many times this year.
Oh God, spectroscopy.
Beer's law is back.
Screw Beer's law. Beer's law sucks.
Remember, it's A equals ABC.
Oh, yeah.
And it's on the reference sheet too.
Is it capital A or lowercase a?
It's capital A equals lowercase ABC.
I'm hungry.
This is the every question test. That's the
Hey,
Mr. Mac, don't you love this?
Sorry for the interruption.
Rate laws?
Huh?
Rate laws?
No.
Can I go to your
No.
What is that unit?
Molarity. Molarity per
Inverse
second.
molarity, so per molarity squared per second?
This is a constant to get rid of the molarity squared. That's why it's molarity to the -2.
Oh,
God, Mr. White.
That was the best roasting ever, obviously.
that's such a nice friendship.
Alright, so spectroscopy, we've seen this before, guys. A equals ABC, and the main reason this keeps popping up, 2 reasons. College Board loves this. They must have, because this is actually a recent thing. Like, they try to act like this was something that was there all along. This is actually a fairly recent phenomenon, the Beer's Law stuff. So what it looks like happened is someone in College Board probably invented this or like had a part in the paper on this. That's why it keeps appearing. But anyway, the reason we see this so often is so many times this year, guys, what have we needed to do things? And this is one of our main ways to find concentration using equipment.
I mean, like,
The guy was drunk.
He was
he was chugging it down.
3 experiments were conducted at 25 Celsius for the following reaction, which occurred in a 1 centimeter cuvette. Guys, this part's important. What letter in ABC is this?
B.
Path length B. Right there. Very good. Okay.
B for Beer's Law.
So they want us to find the rate law and the rate constant at this temperature. Notice though, guys, what did they really give us here?
Concentrations.
They gave us initial concentrations at different times, right? So what we're going to do is we're going to find the lowercase a. Hey, welcome back. We're going to find lowercase a, known as molar absorptivity. We're going to plug in our values. Now, notice we're going to use a data point from any part of the graph where C is known. Let's go back there. So in other words, guys, which one did they end up picking here? We picked 0.2 molarity. So it looks like right around, oh wait, that's A. So they picked one of these two. Which one was it?
Why is it not A and B anymore? Why is it B and C?
Huh?
Why is it not A and B anymore?
Which part? Whoa. There's been many A's and B's today. Not in this class though.
I don't know if it's
Dang. Why are you gotta do it like
I had a B last quarter.
I don't know if it's relevant.
that? There's like 30 of us and one of you. Okay, come on.
All right. Where were we, Victoria?
I don't know if it's relevant, but when it's B plus C equals D plus E.
No. This is Beer's Law, right?
That's not. Yeah, no, I know. But on the last slide. Never mind. I don't think it's relevant.
Oh, okay. Yeah. So we've changed the letters. Instead of A and B, it's now B and C here. Nothing to do with anything. It was just what they chose to do.
Oh, fun.
Yes, sir.
So just to confirm, if like the graph, like the line was a little bit screwed, it'll be a smudge, right? Like a smudge.
Yeah.
That's if this was the word part of the question, not math part. Yes.
Okay.
The smudge. You need to clean it thoroughly.
No. Sometimes it's a smudge. Sometimes it's imperfection on the cuvette.
So, and sometimes, what was it? It was the fingerprint. He
The
changed it up
fingerprint.
every
Oh, there's
time.
a fingerprint, smudge. And you know what the best part is? Kids get that wrong so much still.
I got it wrong 3 times in a row.
I got it wrong.
I don't think I've ever gotten maybe I'm wrong or two, but like usually I get it wrong because I always forget which one it is.
He changes it up.
And don't forget.
Did you put the fingerprint question back? The smudge question?
You only changed the one.
Anyway, let's move on here. So, we can pick any point on the graph. We're gonna pick the one where we're looking for C. So we could do either any of these. We're gonna do this one because C is 0.2. And so then what that allows us to do, we'll get our A and our time there. So we got our B, which is our cuvette. We've got our A, 1.00. And so we get our molar absorptivity is 5.0 and 1 over molarity times centimeters. Okay, that's going to be our absorptivity, our little a. So first things first, we typically try to find a little a.
So usually it depends on whatever variables they give us, right?
Yes, and you just got to kind of, work your way around. The formula is always going to be the same. A equals ABC.
Yeah.
and you just kind of, and your hint that it's on A equals ABC is you'll see something about absorptivity or Beer's law. Like they'll give you some words that give you the hint, and then you know you got to use it.
Oh, I have a question.
What's up?
Alright, so I know that we're finding the one for the colors, which is okay, so we're finding it for C. And so we use the one that's different, which is 0.2, because there are two that are 0.1. And then, where did you get the, never mind.
The 1 centimeter is the B, the path length.
Yeah.
The
And then
0.2 is because that's what we were looking at. We looked at the graph where it started out as 0.2.
Wait, so why is it?
And the 1 comes from the fact that this is where it started. Because look at what these values are, guys. These are initial. So initially we're looking at this one right here.
So why again are we using the green, like the C instead of?
Because Beer's the Beer's law equipment prefers things that are colored because it blocks the light.
Okay.
So beer equipment is distillery prefers things that are green.
No. It shines a laser through it.
Ah.
And then if it blocks the laser, that tells you the concentration with Beer's law.
I think my phone's gonna die soon.
You need a charge?
Here,
we'll charge it real quick.
Well, it's also recording a video, so I just have